Hi, a viewer called Lee asked would I be to have a look at this 4000 watt pure sine wave inverter. I've just got it hooked up to the bench power supply here. I'll just switch it on. And he said it's pretty much dead. This is the second one that he's had because the first one went dead. So this is the button at the front here. We've got no signs of life there. And the only thing that's happening is that the fan's running. So let's take it apart and we'll see if we can figure out what's wrong with it. And seeing this is the second one that he's had that's failed, I'm not too confident with this. I think this might be some kind of design fault. So we'll have a look and we'll see what we can work out. Right, so I've just managed to get the top off. It was screwed on with screws on the sides here. And I've had to undo this bolt just so I've got a bit more play on the cables, and it's still not great because you still can't move it for all these cables here, which are bolted on down here, so it's a little bit hard to work on. So one thing that I have noticed is that some of the fuses are actually different. Because if we look here, we've got 5 of them that are 25 amp and these 2 are 30, and the same here. But I think he did say in the email that some of the fuses were blown. So I'm not sure whether he's trying to replace some of them with 30 amps. I'm not 100% on that. But let's just check to see if any of those are intact. If I put the meter down there, maybe you can see it better. Right, let's check some of these fuses then. Well, that's open circuit. Because they're in parallel, I'm just need to check one of them. Let's just try here. Checking my meter's still working. So it looks like every single fuse is blown in this. So it looks like they've got 8 500 watt inverters in here to give a combined total of 4000. So I'm just wondering what would cause all of these to blow. I think there must be something wrong on the control side of this that's gone. Because I think if, let's say, those MOSFETs had gone, it should in theory just taken out those fuses. I mean, unless some of the MOSFETs have gone and it's shorted out one of the control lines, so then all of the other ones couldn't switch perhaps. In any case, it doesn't look good. So it looks like we've got a 5-volt regulator here. I'm not sure what that one is, but by the look of it, it looks like it's some kind of voltage regulator as well. I'll just try and zoom back out and I'll see if I can see that with the spyglass. And that one is a 7815, so we've got a 15-volt regulator and a 5-volt regulator. Let's just see what readings we get on those. So we've got almost dead short on those. And the same on that one. We've got 2 little subboards here. Let's just try and zoom down on those a bit. Right, let's find something to point with here. We've got a big crater in here on the control board. And no doubt that's controlled by this PIC microcontroller. So this little subboard looks damaged. And I wonder if we can check this PIC micro somehow. Let's just try measuring some of the... I'm just measuring one of the caps on here. So this is one of the supply caps. I've got 37 ohms there. So I don't think this is looking repairable myself. And like I said, this is the second one that he's had. I think this one lasted a few days or a week or so. So the company sent him a replacement one out. And I think that one lasted about the same length of time. So I think he's bought a Victron one now. So, but he just asked, could I have a look at this just to find out what was wrong with it. I mean, we can try checking some of these MOSFETs and that and stuff, but I don't know whether it's worth taking it any further. I doubt you'd be to buy one of these little subboards separately. And then the price of replacing whatever MOSFETs have gone, and for it only to blow up again, by the look of things. I'm going to have a look to see if I can find any reviews on these. I'm just curious. So I've had a look at some of the reviews online and it's quite a mixed bag. There's quite a few people have mentioned that they're on the second inverter because the first one's blew up and then they've sent out another one, and then somebody mentioned that one of them burnt his house down, and yeah, so let's just check some of these MOSFETs here. I've just disconnected this top board so it's easier to get at. Well, those ones seem okay. Just checking to see if we've got any shorts in any of these. Nah. Right, well that one's short. That one's short. And that's the ones where the fuses have been changed. Let's just try these. So it appears that those four MOSFETs there are faulty. Let's get this bit out of the way and we'll have a look at the bottom board. Let's just try the same again. So it looks like those four are faulty. And those four might well be okay. So we could replace the MOSFETs, but I'm more worried about this board here, which seems to be the main controller. What I might do, because I'm going to have to get this board out in any case, because that chip has definitely failed, but I'm more bothered about whether it's taken this PIC microcontroller out, because if it has, then it's pretty much game over. So I might see if I can get this board out. We'll remove this module here. And then I might see if I can supply 5 volts into it. I'll probably have to take that chip off first and we'll see if any of these other chips get hot. And if they do, well, that's it, pretty much game over. But we'll have a go. So I've just been undoing all of the heatsink bar and that and stuff here. And I've just noticed this as well. Yeah, it's looking more and more unlikely that this is going to be repairable. So it looks like not only the low voltage side has got problems, but also on the high voltage side as well, because this is one of the MOSFETs that takes the high voltage DC that comes from these transformers here, charges up these caps, and then this is what creates the AC with these transformers here. But we'll get it out anyway. Like I say, I'm curious to see if this PIC microcontroller's gone, which I suspect it has. So I was just moving that slightly forward and the whole thing just fell off. So I wonder if the legs have been weakened on this or something, or whether, I've not really seen a one fail like that before. Well, the legs are blown off. It looks more like mechanical, that. So I'm just wondering whether when it's been in transit, if these have been brittle and they've kind of fractured with vibration or something, and that's what's caused the initial failure. Interesting. Right, got the board out, so I'm going to use my solder sucker just to try and remove this module here. So I'll just switch that on and wait for it to warm up, and then we'll start removing it. Right, I've got the little subboard removed and under the microscope here. This is one of the ICs there, it's got a big hole in it. And it looks like this one is also blown. Looks like it's got a big hole in it there. Yeah. What's this here? I can kind of see a mark there. Just a scratch, or is that lifted up? I think that's lifted up. Let's try and zoom down a bit on that. Yeah, that's lifted up, that. So it looks like we've got a big crack in this pick chip here. Well, that's a shame. So it looks like this isn't going to be repairable because that pick chip will contain code, so even if we've got a replacement pick chip, it's not going to work because we haven't got the code to program into it. And you can see it there, that bit there sticking up. So it looks like it's getting back into that chip as well. Well, that's a shame. I still might put 5, well actually we'll just measure what resistance we get between the supply. So let's just go onto this chip here. Yeah, we've got 38 ohms across the supply there. I might just remove these 2 chips just to prove on the camera that pick chip's gone. So let's just do that. Right, that's those 2 chips removed. Let's just check across this capacitor here. And we've got 40 ohms now. Let's just inject some voltage here because that's ground in any case. And that'll be the 5-volt supply. So let's put 5 volts into here across this capacitor and we'll see what gets hot. Right, I've got the bench power supply set up at 1 volt at 1 amp. So we'll just switch it on. It doesn't seem to be drawn a lot. Let's just try change it to 5 volts. There we go. Yeah, so it's heating up there. Nearly 50 degrees now. It doesn't appear that anything else on the board's heating up. Just that IC. Well, more of an autopsy than a repair. So that's unfortunately as far as we can take this one. Right then, if you enjoyed this video, please give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.